Okay, so we're moving on to exercise 3 now. If you haven't watched the last video, we did exercise 1 and 2 in the last video. You can click that here. Let's get started. Where are we? Exercise 2, we've done that. All right, so the sinusoidal voltage displayed on an oscilloscope has a peak amplitude of 3.15 volts. What is the RMS value of the waveform? Okay, so we've got a sine voltage and displayed on an oscilloscope, that's irrelevant. So it's got a peak amplitude. So peak voltage is, the V peak is equal to 3.15 volts. We know to get the RMS, we just do so voltage RMS is equal to voltage peak times 0.717, I believe. This is the next morning. If you're watching from my last video, you know, I went to bed, went to car boot sale, so it's about 12 hours later, and I've forgotten some stuff. So let's have a look. We times by 1.414 when we got voltage peak to find the voltage peak. But to go the other way, I'm pretty sure we times by yeah, there we go. So to find voltage RMS, we do 0.707 times the voltage peak. 707. What did I write? 717. Okay, I was close. Not too shabby, huh? So 07. Cool. So that just means 3.15 times 0.707 is going to be equal to the voltage RMS. So let's get a calculator. Was it 3.15 times 0.707? And so that gives us a voltage RMS of 2.22705, or voltage RMS of 2.23 volts. So it's fairly straightforward to think about in terms of when you just got to remember whether you're timesing by 0.707 or whether you're timesing by 1.414. And I suppose the only way you know the difference is if you've got voltage peak, that's obviously the higher amount. So there's no way you're going to be multiplying by 1.414 to get, high, or to get the RMS. The RMS is going to be lower. So then you're multiplying by 0.707, right? So that's our answer, 2.23 volts. Let's have a look. There we go, nice. This is another way that I kind of like. So what you basically do there is instead of timesing by 0.707, you just divide. So you take 3.15 and you divide it by 1.414. So it's just a case of remembering whether you're multiplying or dividing, and then that way you only have one number to remember. So that might be easier. Maybe we try that out on the next one. Okay, so let's have a look at this example 4. Again, like I said, if this is over your head, watch the last video and one before that. Okay, so a 200 watt resistive element in a heater is connected to a 120 volt outlet. 200 watt resistive. Okay, let's just write down some stuff. So 200 watt, we've got 120 volts. We're dealing with power, right? That's obviously AC. How much current is flowing through the resistive element? So we're just looking at the power equation, P equals IV, or the actual RMS power one, which is this one here. Right? So we got P is equal to I RMS times V RMS. So I didn't read the whole question. Let's just make sure. How much current is flowing through the resistive element? What's the resistance of the element, assuming it's an ideal resistor? Okay. So we just do P divided by V, and that will give us I. That's just Ohm's law manipulation, right? Or the power law manipulation. Okay, so that means we take 200 watts and we divide it by 120 volts, and that will give us the current. So let's get calculate back up. 200 watts divided by 120 volts. That means we have 1.67 amps going through the resistive element. Okay, And then, so what's the resistance of the element, assuming it's an idle resistor? So now that you've got the current, this is quite cool, you know, the fact that like you can just be given two values and then you can work out so many other things from that because of these laws. It's quite cool that we actually have laws, you know. How does electricity have laws? Interesting. All right, so to work out the resistance, then we're just doing Ohm's law, V equals IR. And so we already have V and we already have I. So V divided by I, and that would give us a resistance. That means the resistance is equal to 120 volts divided by 1.67 amps. And that gives us 120 volts divided by 1.67 amps. And so we get a resistance of 7.186 ohms. Which obviously for a resistor, you just round up to 72 ohms, wouldn't you? So how are we doing? So I RMS is equal to P average divided by V RMS. That gives you 200 watts divided by 120 volts, which is 1.7 amps, which is what we got. Oh, we got 1.67. So yeah, wrong. I'm joking, but we should round it up. That's fine. The 1.67 amps. And then the resistance is equal to VRMS divided by IRMS, which is 120 volts divided by 1.7 amps, and that gives you 72 ohms, which you got correct as well. Nice. I'm enjoying this. See, I don't like maths, and obviously this is quite basic maths anyway, so it's not really like anything special. But you know, it's nice to. I don't mind doing maths when it involves electronic stuff because I'm passionate about electronics. So I want to learn it, and so learning it, maths as a byproduct, I enjoy. Okay, so example 5. So we've got example 5 and example 6, and then we'll wrap this video up because I am keen. Keep the videos nice and short. All right, so let's go example 6. Also, I need a nap. I'm getting old. Got up early this morning to go to a car boot show. All right, so example 5. Assign voltage supplied by a function generator. Okay, too many words for me. So anyways, a sine wave, right, by a function generator, cool, all irrelevant information. It's specified as a 20 volt peak to peak. Interesting. I haven't really dug into this peak to peak stuff or frequency really. I mean, I know we've touched on it, but I haven't done a calculation for it yet. So let's see how this goes. This is going to be an interesting experiment. So we've got 20 volts and this is peak to peak. So how do you denote peak to peak? That's like P to P. Was it play to win or pay to play or something? Yeah, pay to play. If you're a gamer, you know what that means, P to P. Okay, so we've got 20 volts peak to peak, and we've got 100 hertz. 100 hertz or 1,000? 1,000 hertz frequency. What is the minimum resistance? Wow, we're talking about resistance. Okay, what is the minimum resistance value of a 1/8 watt? What, mate? What is the minimum resistance value of a 1/8 watt resistor you can place? Huh? Okay, I want to try and understand this before I read the answer. Let's write that down. So, what is minimum resistance value? Resistance for, why is it 1/8 watt resistor? In place across the generator's output before exceeding the resistor's power rating. So, we're trying to find the power rating of the resistor. So, I assume we're just doing P is equal to VI. How are we getting I? So we've got voltage, which is 20 volts, and that's peak to peak. So let's go. They had a relationships thing here, which was in the last video. You see this stuff here. So we're gonna have to use one of these peak to peak things. Okay, so okay, nice. So this is interesting. So peak to peak. So you got peak to peak value. To get that to the peak, you just obviously half it, right? So that gives you 10 volts. So that means that so our 20 volts peak to peak is equal to a 10 volt peak. Okay, so what's peak to peak? Is peak to peak this, right? Are we saying you go from here to here? Is that peak to peak? Do you see what I did there? So here to here. That must be it, right? Oh yeah, it is. Look, that's it. Ah, nice. I get it. I didn't understand. I was thinking that peak to peak was like this point over to the next peak of the next cycle. Oh, I'm so happy I get that. Yes. Okay, so I'd like to put this in my notes somewhere. Here we go. Okay, so let's do this. Peak to peak one. Okay, so let's say this was 12 volts. This was minus 12 volts. Then peak to peak is equal to 24 volts. Oh, I'm excited about that. Okay, so hopefully you guys get that, right? The peak voltage is from here to here. Okay, so let's carry on then. I'm excited about that. So we've got peak to peak, and now we've got peak because you're just halving it. And then to get the RMS value from the peak, you just take the peak, the 10 volts, and you times it by 0.7. Was it 0.7? Yeah. 10. It's actually 0.7071. But I don't think that one really makes a difference. Quite insignificant. But that's fine. Let's do 10 volts times 0.7071. And then obviously, yeah, that gives us 7.07 volts. I didn't need to calculate for that. 7.07 volts. And this is our RMS value. Okay, so now we've got our voltage RMS. Do we have our power rating? We're saying that what is the minimum resistance for a 1/8 watt? 1/8 watts. So that's just like decimal, basically. You're just telling me that it's a decimal, isn't it, right? Where's the question? Here. 1/8 watt. What's an eighth of a watt? Calculator, make my life easy. What's an okay? What's an eighth as a fraction, people? Someone help me out. One. Sorry, not as a fraction, as a decimal. 0.125. Okay, so you got a 0.125 watt, and that's the power rating. So now we've got P is equal to VI. And so to find the current, what are we trying to do? We're trying to find resistance. Okay. So to find the current, we do P divided by V is equal to I. And that basically means that we take 0.125 and we divide it by 7.07, and that will give us the current, which is 0.125 divided by 7.07. And so the current is 0.01768 or 77. Okay, so what's that? That's 17.7 milliamps, right? Okay, I'm gonna keep it as just as amps for now. 0.0177, just because it's easy. I'm less likely to make a mistake when I'm calculating. So I've got current now, and I'm trying to find the minimum resistance value. So then it's just V is equal to IR. So V divided by I is equal to R. So we just take 7.07 volts divided by 0.0177 amps. And that will give us the resistance, which is 7.07 divided by 0.0177. 0.0177. Man, I forgot to record my screen again, man. I keep doing this. My iPad screen. Dude, I'm just sorry guys. Okay. That's annoying. Alright, where's my calculator? So then that's 399. Apologies guys. This is the part where, you know, I really needed to show you my workings. I'll put a screenshot of my notes, but annoying, man. This is why I need to take naps, okay? I'm 28 years old now. I'm getting old. 399.43. I'm so bummed out I didn't take notes, man. Well, I was obviously taking notes, but I wasn't recording my screen. So that's basically a 400 ohm resistor. And I think that's it. So what was the question? The question was, what's the minimum resistance value of a 1/8 watt resistor you can place across the generator's output before exceeding resistor power rating? So all of this could be completely wrong. And we're going to find out now. Literally, look, it took me all of that to do just that question. Let's see if I did it right. So we got, oh look, 400 ohms. Haha, nice. Very happy about that. But I got it right. That's crazy. That is crazy. I'm very proud of that. Okay, so we've got voltage peak is half of voltage peak to peak. See, I got it right. Obviously, it told me up there, which is 10 volts. The voltage RMS is 0.707 times the voltage peak, and that equals 7.1 volts AC. Then you get R is equal to, that's quicker. So basically what they did there was they just said, okay, so we've got, so I worked out current, but obviously there was no need. True, there was no need. You can obviously work out resistance straight from the power, because resistance is equal to voltage squared divided by power. Dums. That's why you want to get a bit comfortable with the manipulation of Ohm's law, the manipulation of the power law. Okay. So you take 7.1, you square it, and you divide it by 1/8, which 1/8 is 0.125, and that gives you 400 ohms. Sick. Oh, I'm excited, man. This is good. I'm enjoying this. I'm really, really enjoying this. Okay. So let's do the final example then, example 6. So we've got the output of an oscilloscope. The output of an oscillator circuit is specified as 600 millivolts. 180, can't bloody read. 680 millivolts, which is 0.68 volts. If you feed this into an op amp, bloody hell, this is what I really need to get to. Op amps. I really need to learn about op amps. If you feed this into an op amp with an input resistance of 10 mega ohms, which is 10 million ohms, right? Yeah. So 10 mega ohms. How much current enters the IC? IC referring to op amp, right? So don't op amps don't draw current, but obviously, sure you haven't. Oh, it's an oscillator. It's an oscillator circuit, huh? The output of an oscillator circuit is specified. I'm sure okay, no, ideal op amps don't, but this one's probably obviously it's got 10 million ohms input resistance. Okay, yeah, because op amps don't obviously. Okay, forget about what I'm saying to you. If you haven't studied op amps, then what I'm saying doesn't make any sense, and we don't need it. We don't need to know this in order to do this question. So let me just shut up and let's just do this question. So what do we have? We've got voltage, we got ohms, and we want to know current. So it's just simply current is equal to voltage divided by resistance, right? Voltage RMS. So IRMS is equal to voltage RMS divided by resistance. So we literally just take 0.68 volts. The trick here is to not do 680 because it's in millivolts, right? And then we divide that by 10 million. So what's 10 million? Is that like, how do you write that in engineering notation? Is it like E to the 6 or something? I don't know. I can't remember engineering notation. Let me just be a bum and just write out the whole 10 million. Cool. And so that is then equal to, it's gonna be lots of zeros. You're basically adding on 7 zeros. So it should be 0.1, 2, 3, 4, 5, 6, 7, 6, 8. Am I right? Yeah, here. Okay, so how many zeros are added? 1, 2, 3, 4, 5, 6, 7, 6, 8. And that equals to 6 nanoamps. I should have actually converted that actually. That's a good point. 68 nanoamps. I'm really not good at SI units. Get a chart here. Okay. So nano is a lot. Okay, no, it is, yeah. 9. Okay. 3, 6, 7, 8. This is 8 zeros. Is this right? What's between micro and nano? So you got 5 zeros, 6, 3, 6, 7, 8. I'm a Dumbo. Obviously, this is 1 nanosecond or 1 nano amp. And then this would be 10 nanoamps and 100 nanoamps. So we've got 7, 1, 3, 6, 7. That gives us 68 nanoamps, obviously. Yeah, that's dumb. I'm being dumb. Don't mind me. And yeah, that's it. So, they just finish it off with this bit here. But yeah, like I said, I'll keep this video short. So we will read this bit in the next video. And I'm enjoying this. Hopefully you are. And I apologize for not recording my iPad screen earlier. I'll stick a screenshot up of what I did in that part of the video. I mean, it's just here, if you can see. Yeah, it's annoying. I should have, I wish I was recording it. I'll try and, I might stick a post-it note on my screen or something. Cool, guys. All right. I shall go have a nap, and then we'll carry on with this in the next video. Peace.